intro, and then we'll start. Hey! Welcome to a new episode of SDV Coffee Talk. After a long summer break, I have two exciting guests with me, Robert and Emil. Florian cannot join, unfortunately, because he's on a conference at the moment. But I think we have a lot of topics to talk with Emil and Robert together. I think it will be an exciting session. What we will talk about is actually our topic is around. We will have an introduction round, and we will talk about the EAA a little bit. Recently happened. Emil was there on the conference, and he will just give some insights. Then we will switch to an integration topic in SDV. This is a very hot topic, actually. How OEMs deal with that, and if they are ready for doing this. Let's have an introduction round. A disclaimer from my side. I mean, everything what I say is my own opinion and has nothing to do with my employer. Let's start. Emil, you want to start?
Sure. Thanks, Fatih, for inviting me, and an honor being here with Mr. Broken Testing, Robert himself. So my background is engineer by training, but I've been doing sales and business development for quite a while, and started out in mobile phone area, but then 2007 I was working for a Swedish company called TAT, the Astonishing Tribe. We were doing like user interfaces for mobile phones, and then the automotive start to knock on the door. We have crappy UIs in the cars, you have good UIs in the phone. How could we get the similar look and feel in the cars back 2007? So and I've been doing automotive since then. Nowadays I'm with a Swedish startup called Remotive Labs, so we are doing a vehicle simulation platform. So that was the short intro from my side.
Thanks, Emil. Then I will take over. So hello, everybody joining this SDV. I don't know why it's coffee talk. It should be a beer talk. That would be better. Could also be alcohol free. Okay, sorry, I was not aware of that party. So let me shortly introduce. So my name is Robert Fay. Since a half year, I'm also known as Mr. Broken Testing. My hobby is to think and talk and do testing. At the moment, I'm the product management responsible for the TPT solution. That's a test automation used in automotive. And I have a long footprint in automotive. So I made my diploma thesis at VW Group, joined a software company within the VW Group, the Carmack. I spent there more than 10 years as a developer, engineer, project manager in software projects, bring several components into series, got a team lead, got some kind of a director, setting up integration development toolchain, changing or going to carry it and helping to set up IT process method and tool in the carry it. And left carry it in 2021, going to PikeTech. PikeTech was the vendor or the original vendor of TPT. And PikeTech was acquired by Synopsys closely 2 years and 2 months ago. And now I can do what my heart feels are doing in explaining testing in the best way for automotive.
Cool, thanks. I mean, we want to actually talk about integration problems, but probably, Emil, you can give some impressions from the recently happening IAA. You were there. What was there? Something new, something disruptive the OEMs brought? What's something interesting there? Or some boring stuff? I don't know.
I would say it was a good mixture between stuff. So, it wasn't like pure tech. It wasn't like pure automotive, but it was like a mixture between tech companies. So the big ones were there, like Amazon and Google, and they had a partner network. So there starts to be a movement connected to collaboration, because people start to figure out we can't do everything by ourselves. Let's focus on what I'm best on, and then bring partners in and collaborate on the stuff. And still seeing that the automotive guys were there, and actually a big German presence as it was in Munich, but also many Chinese players there. So it's a mixture between a lot of different things. And I thought that was let's say a nice feeling, because when you're bringing up a new vehicle, it's a combination, right? You still need the good hardware, and you need to be able to bend metals and have a good feeling inside the car, but we're filling the car with more tech and software as well. So that's the combination.
Anything disruptive, actually? I mean, something really new, what you say, where you can say, wow, this is really impressive also, or just the old boring stuff, you show a new car, I mean, I think nowadays we are used to have this disruptive things, if there's nothing new, then it becomes somehow usual stuff. I'm not sure. I mean, if there was something similar there.
I think it was a bit disruptive is to see all these Chinese players in Germany as well, and they're coming like from the tech industry as well, and some naturally they have their automotive background, but some others they really don't, coming from the EV world. And now everybody's talking about how can they squeeze out cars in a year and a half. We need like 4 years instead. So many people are starting to talk about China speed and how can we achieve it. So it's like the combination of SDV still exists and talking about SDVs, but still, okay, how can we reach China speed? We need to be able to squeeze out things much faster.
But what is meant actually by, but I mean, I hear this very, very often, or read this in posts on LinkedIn or so, China speed. What is actually meant by that? I mean, what exactly is meant by China speed?
I think my impression is that traditional automotive OEMs, they need like 3-4 years to squeeze out a new model, right? While the Chinese can do it in a year and a half. So thinking of, I need to be much faster. But I'm not sure that that's like the key thing. Do traditional automotive OEM need to squeeze out a car in a year and a half? I don't think that's like the main point. Main point is having control over your own destiny. If I'm saying, okay, I will develop a very advanced car, I want it to be launched in 2.5 years or 3 years, but I want it to be launched then 3 years, not a year too late, because then I'm not controlling my destiny.
Okay. Robert, actually, what is your understanding of this China speed? I think you also somehow hear this very often, also from your perspective.
Yeah, everybody talks about that, but
exactly.
I think there is not really a definition for that, or I'm not aware of a clear definition. But what we see is a lot of models, a lot of types are coming in a very fast frequency on the market, and that is something I just discovered a couple of weeks ago. There's a diploma thesis of a student from VW Group explaining that the goal of automotive OEMs is to reduce the time to market for a new model and introduced simultaneous engineering. This diploma thesis is 20 years old, and he said that was like 4 years, 3.5 years for starting a new car project until it's until the SOP is until the you can go to market. And that is a wish of all the automotive OEMs ever. So they ever try to build faster new cars to get faster into market, because that increases the sellings.
But there is one thing which comes in my mind. I mean, if we say, for example, okay, faster, yeah, it's fine. Also, Philip Ahmad is also in the. He's one of. He wrote a comment that he was also a guest in one of my episodes before about open source, and he's writing from requirement to SOP in 50 months. China speed. I mean, this sounds very impressive actually, but I think. I mean, I work also in this area not so long like you guys, but also a couple of years. But in automotive, we have a lot of regulations, a lot of regulations, safety, security, whatever things. And fulfilling all these regulations needs some time. I mean, it's not so easy. And I don't know how this China OEMs can do that, actually. How they can fulfill all this stuff in 50 months. I mean, This is not so clear to me. I don't know if you have any insights on that. I mean,
I think there is some change, or there are some regional changes between these countries. So if you look between Europe and the US, there is different kind of type approvals. So while I hope I'm correct, so I don't want to make it misleading. In Germany, you need a lot of approvals. You have to go to legal government authorities and to check your car. So for different kind of
exactly. Yes.
regulations. So in
Yes.
US you do it on your own. So and depending on where you want to go with your car and which kind of market, it's easier or harder to fulfill these requirements. And as you know, it's much easier to make a self-assessment than to get assessed. So everybody who made an automotive spice assessment will know that internal assessment is quite easier than external assessments, because they look, or they have another kind of controlling, they have another kind of what they are looking for, and they will find things. So and if the market entry is quite easy in China, then of course you can go faster into the market. And
Okay.
I saw also in the announcement, you saw there are also some problems with this car in China. So it's not that everything is gold in China. So they are quite fast going into the market, but they also have recalls, and they're also
This is
struggling
exactly
with
my
a lot of
point. This is
topics.
exactly my point. I mean, you can be fast, but if you have to, call back many, millions of cars, I mean, what is then the advantage? Because this is costs, a lot of costs, and this is not so easy. I'm not really sure if this is the right way, because everybody is talking about China speed, and I'm quite skeptical with that, to be honest. I mean, Emil, I don't know if you have any insights from your side
Yeah,
about
I'm sure
this.
there is like a balance between, okay, do I want to develop the perfect car, and that takes longer time, or I squeeze something out that maybe misses a couple of features, but I know if I have OTA possibilities, I can update it afterwards. But I think also, like, maybe there isn't the need from those guys to actually optimize everything. So like, instead of like going to the chipset vendors, okay, I want this and this special solution, then I say, okay, what do you have off the shelf? I'll take your more or less standard SDK and then I implement it in the car. So that's also a way of like saving development time. Do you want the perfect solution or something that's, okay, this fulfills my need, I'll go with it.
Yeah, but how this can be explained then, the prices of China cars? I mean, these are up-to-date cars actually, but for tiny portion of the money you would pay here in Europe, for a European car. How this can work? I mean, I don't know. They have to, in my opinion, they have to cut somewhere. I mean, you cannot make a car cheaper and cheaper, because the production costs are more or less the same, I guess. And with all, if you want to consider safety, security, all this stuff, we will come later also in the integration process. I think this is also quite important there. I think the cost must be similar. I mean, I cannot understand this actually, where this small, these cheap numbers for prices come from.
I think one of the biggest driver in development is man-hour price. So, and if we go to China, it is cheaper, so you can also spend more workforce for the development of cars. So I think that is quite clear. So we know that in Europe the prices are more, I would say it's 5 to 10 times higher than in some Asian countries. So like I heard, for example, I know from testing, so testing services in India for unit testing, I heard from prices, so it's $18 an hour, and sometimes it goes beyond $8. So from Vietnam and from India, so that is prices you cannot compete with Germany because of our regulations. So workforce is also one of the main driver of development costs. So what should be comparable is cost per parts. So if you find suppliers developing also in, let's say, low cost countries parts of their car within this country without let's rethink how bigger tier ones are developing components. They try to find multiple OEMs taking the same kind of let's say body controller or motor controller and want to deploy to multiple customers, and that needs variants in the software, needs variants in the infrastructure, and you can save a lot if you go down with your process and quality requirements. So I think that is a mixture. So a mix of processes, quality, people, workforce, what is available. So multiple reasons.
But
And
I mean, yeah.
And Andrew Bullen said everything is cheaper in China. Thanks, Andrew.
Yeah, but the thing, I mean, were there any promises from the China OEMs on the ERR actually, Emil? I mean, that said we are better, we are greater, we are something. I mean, what was their, slogan more or less, and what did they, how they want to attract people? I mean, with the prices only?
And they're making like fancy cars as well, at least from the outside.
Okay.
I haven't owned one, so I can't say if they're better, worse, or on par, but they look fancy at least from the outside, and there's a lot of features there, and so they're not missing on that part at least.
Okay.
But when you recap, Emil, when you recap your IAA experience, so and you compare Chinese cars with, let's say, European premium cars, can you discover any differences in kinds of features or hardware? Can you distinguish between that?
And not really. And the question is how it will last if you owning a car for a longer time. That I'm not sure. But like say, if you're just looking at features and what you have in the cars, like looking at the displays and electrical chairs and whatever more, there's no difference on that side.
So the thing the Germans were proud of cool looking cars. That is what everybody now said. So that is not differentiating anymore.
No, so the question is what more will be coming, and maybe it's like this whole SDV story. So if you buy a very nice German car, can you keep it alive for a long time with getting new features in there via software updates? So this could naturally be something where you really have advantage of having a high quality car with nice leather and nice wood and whatever more is in there, of course, and keeping it fresh continuously.
I think this is probably also one of the key points. I mean, Thomas is pointing out here that it's something like enter the market as fast as possible and fix it later over OTA updates. I think this is still a very big issue for all OEMs in Europe, especially having a stable OTA update procedure. But I think this has also to do with what we want to talk about today, about the integration challenge, so to say. Where do you see actually, Emil, the European OEMs at the moment with this topic? I mean, integration in this context, because they have a lot of problems, I guess. I mean,
in general, and then like going back to like everybody's talking about the SDVs and we want to reach China speed, but what's actually being done? And if you're looking into this, okay, maybe we don't need to develop car in a year and a half. Maybe it's good enough with 2 years or 3 years, but to know that, okay, when I set, okay, I want to launch the car, then it should be ready. Because then if you're looking into the model, like we're used to working right now, so you have an OEM that creates a specification, and then they send a spec out in Excel sheet, whatever, to their suppliers. That's fulfill. Okay, please, Mr. Tier 1 supplier, fulfill this Excel sheet for me. And then you're following the V model, you're developing stuff, components, and then you're starting to test some smaller pieces. And then at the end, 2-3 years later, OEMs getting all the pieces from the different suppliers. And then, bang, integration, nothing works. Where's the issue? Nobody knows because we didn't test the system.
This is such a known story, actually.
Yes, it's like the Big Bang integration. Yes. It's like the chances that will work with getting, regardless
Zero.
if it's
Zero.
if it's 100 different ECUs, or if you have a domain controllers or zonal controls, doesn't matter, right? It's the same number of application. It's maybe a bit easier to test if you're developing a bit bigger chunk of it, but it's still the same issue, right? The software becomes more and more complex. There's more software in the cars, and you're getting more and more intertwined interactions between different applications. So, and you need to start to test this from day one.
Yeah, but how, I mean, this is also a problem of ownership, I think. I mean, this is because if you give the ownership to your suppliers and say, okay, deliver me just the software, I think you will never control the integration process itself, because you're not owning it, and you will face a lot of issues because you have hundreds of suppliers, and they use the same. I mean, you need to be sure that the interfaces are the same. I mean, otherwise your ECU network will not work. I mean, this is for sure.
Maybe, Fadi, I can share another story. I was on a IEEE event on a conference, and I shared the same story. I made some analysis from a normal OEM and how the integration process works, and I can share some insights. So there are already tests. So if you look on an application development team, you see, let's say it's 5 to 10 developers, and there is a testing team, and they do a really great job. So they develop on the software. Mostly it is also product driven. So that means they iterate over multiple hardware generations into multiple ECUs. So these application teams are already working for what we would say, what should be the working model for the entire SDV. But then there's the problem, and that is always the handover point from an application team to an integration team. And let's imagine, just for a moment, let's say there's only 5 applications on top of an operating system. And let's imagine further that these applications are quite big. So let's say 1,000, 2,000 interfaces, and maybe some more parameters to make some adaptations for multiple car projects. So, and what happens is you have an integration team which needs to deliver at a certain point, A sample, B sample, C sample, and maybe more smaller steps, but it is milestone driven. That means the integration team has to provide a milestone or release to a specific date in a project schedule. And what happens always is, for the integration team, they set a delivery point for all the applications for being updated. And that is a manual handover. So imagine on, let's say, 1st of October, tomorrow, 50 application teams hand over their release they develop for the last 4, 5, 6 weeks, makes lots of updates, changing interfaces, and now the integration team has to update these components. So if there is no update strategy, if there is no abstraction, if it's not some kind of a POSIX application where everything is connected automatically, if it's out of the software components, you have to rebuild everything. There's a new interface, you have to connect it to another application, you have to connect it to a diagnostic system. That is work somebody has to do. And now imagine further, the guy who does this job, connecting all these pieces, he should, or he is normally, according to the process, he should set up some integration tests. But he has no clue how the component is working, because 10 or 15 people know exactly what the application does, but the integration tester or the integration guy, he has no clue what does mean. So he cannot set up integration with other components, integration vertically, integration step-by-step approaches. So there is a missing really big bang integration. So connect it and pray, make some reviews, pray, ask for help, pray. And I've heard from a company, the integration process took, let's keep staying on a chair, 20 to 24 weeks. After the release, the applications are handed over, the first time the software is able to be built and deployable and then running on a hill system. That means
that's 6 months or so. I mean,
that is 6 months exactly. So imagine six. What have you done 6 months before? I have no clue, and no developer is the same. He has no clue what he do, and that is the biggest problem. So the integration problem is a problem of there is no stage pipelining. It is not a stage commitment where you can see, oh, here is it breaking. Let's move back and reverse this change because it's not working.
But I mean, you mentioned one thing what is very interesting to me, because I think also, I thought about this also a lot. I mean, you mentioned variants, you know. European OEMs have this huge amount of variants, you know. I mean, if I look, for example, to Volkswagen, you know, they have so many brands and so many different, you know, they have a crazy amount of variants. And if you want just one software for all these variants, this becomes such a complex thing, you know. I mean, the integration will be also very painful because you have to test actually for each variant if it works. You know, I'm not really sure if the China OEMs, for example, reduce the variants to make it faster. You know, I mean, I don't know if this is true. I mean, if you have any insights on that from the EIR, but I think probably reducing the variants could be also a strategy to be faster at all. I mean,
that is what we see here. So I saw VW cars are reducing variants. I saw it also, I think, from Mercedes-Benz having the same problems in the past.
Yeah, I would say that's what they're doing. And if you're looking at Tesla or similar, more tech-savvy OEMs that comes from the software side, there's less variants, and naturally that makes life easier. But you need to start somewhere, and I think sometimes the automotive business, at least the traditional one, they're always thinking like in hardware, and that's like the holy grail. And then you'd start to move slowly towards creating something in a virtual environment. But if you're going there, everything needs to be perfect. So I really need my digital twin. It should be a perfect copy of what I have in hardware. But instead of, if you're coming from the software perspective, you're starting from day one and then you're iterating. So that means if Robert develops one application, Fatih, you a second, I a third, you test continuously. Okay, you do an update to your application, Robert. Does it pass the test? Okay, it did. Fine. Then I can commit my code. Then Fatih, you get use of what Robert did. Then you're testing something that's better. Then you're testing your thing, and then you're committing your code, and then you're iterating continuously. And this you can start with from day one. Just having the how the different ECUs behave. If I'm sending signal A in, I'm expecting B back. So that's like the starting point. You can mock the complete vehicle in a virtual environment, because that means we can work together in a context and testing the integration from day one. You still continue to develop your applications, you're developing your MATLAB models, you're adding like Synopsys Silver models, whatever you might have. But it's the continuous iteration of things in a context, not standalone, because then you're getting the integration issue at the end.
I mean, integration, I mean, this you talked about this a couple of minutes before. I mean, this digital twin, having the car, so to say, in the cloud to have this integration beforehand and so on. Is it realistic to achieve this? I'm just asking. I don't know. I mean, I'm just asking. I'm curious about that because I hear also a lot of people talking about that, having a digital twin in the cloud, and you know, you have a parity between cloud and vehicle. I mean, there is also, I mean, I think this is also the claim from Sophie, this industry initiative to have this parity in cloud and vehicle. But I'm not really sure if this is achievable at all. I mean,
it depends on what you want to achieve. So, and I would, from my side, I would like to see a complete mindset, and maybe I'll get some more software guys on this track. Like, the car is still the hardware, but think of if the reference was in the cloud, in the virtual environment, and the car becomes the physical twin, because then you have the reference in the software environment that you're just spinning off to the hardware. Naturally, there is differences, and there's more granularity in hardware, and you still need all the heel rigs and stuff to test things. But from a functionality perspective, you can do all of that in a software environment. There'll always be bottlenecks in hardware, and there'll be memory leaks and congested network buses. But most of the things you can actually test in a virtual environment. And before you go into the heel rigs that are scarce resources and expensive, get rid of all the issues that are connected to integration and all the functionality issues. You can find that in the soft environment, and then you find what's hardware related in the hardware environment. Not everything in hardware, because then you'll get the integration mess.
I mean, this is a very interesting idea, actually. What you told me, that the hardware is actually the twins of the cloud. I mean, that you have this software first mindset, that you develop actually the software for the cloud, and then say, okay, we deploy this on hardware in a vehicle. I mean, this is a different view, because when I talk to people or have discussions, they talk first about the vehicle and say, okay, we have to make this vehicle somehow, copy this into the cloud, not the other way around. I mean, that cloud first approach. I mean, I've never heard this actually. This cloud first approach to say, okay, we actually develop the software for cloud, but it will be deployed on the car later. If it's mature enough.
But let's be careful. So the reason going into cloud and having a digital twin is to ensure fast feedback. So that is the reason. So it makes, from my point of view, it makes no sense to check what some people have in mind, any small change in an entire car setup, because you also have to maintain, you also have to be able to check that. So going back to these high integrated ECU with 50 applications, I've heard from one customer setup, from the outer interface is on a plane. If you make it plain, it's like 100,000 interfaces.
Oh wow!
Okay. So a signal level. So within CAN, within LIN, with IOs. So if you have to stimulate that, so that is not really a fun job of a tester. So and for that you need a rest bus simulation to get it in an up and running mode, and then you have to do a lot of actions. But that does not mean that you are able to test everything, because there are so many connections within the software, especially on your operating system, which is not able to stimulate from outside with a black box testing. So it is necessary to split it, to split your entire stack into, let's say, into slices, and the slices must be testable. And the good news is, if it's in software, you can rely on the results. If it's a deterministic system, you can rely on the results, and you can go from one piece to another piece, integrate pieces together. It's also so-called virtual ECUs, level 1, 2, 3, 4, 4A, 4B. And so you can enable from small to big. And that is the real key to get fast feedback, because what everything is small is easy to test, is easy to slice, is easy to check because of number of interfaces, exhaustive testing, and so on and so on. And then you can rely on these tests and can build a stepwise integration from small parts units up to the entire vehicle level. And of course, in some reasons, you need some checks also on the fully integrated full stack, but it will not check the functionality on a full stack. That is something you already have done on an application layer integration, and then you go, does it work? And you don't have to repeat all the tests. You just repeat a little sum of the existing test set and make a recheck with the new interfaces and check the connectivity in a back-to-back approach to have a validation of your previous test stage. So that's I
have a very fundamental question, actually. I'm questioning very often this, but I never got the satisfying answer. Let's discuss it here. I mean, I think one of the biggest problems we have is that a lot of communication in a vehicle happens over signals. Signal communication is a quite tightly coupled system. You have multiple ECUs. If they use some bus system like CAN, LIN, FlexRay, or whatever, it's tightly coupled. And you cannot isolate it, test it easily. I mean, and I challenge this often to replace actually the signal-based communication with something else. I don't know if you have any ideas there. What could be a replacement for that? But I think to be more, modular, that you have modules which you can test independently and develop independently, and have very clean interfaces where you can say, okay. If the interface, this interface contract is kept by everybody, it will just work. The integration will be much easier. But I think this signal-based communication is a big problem in automotive. I mean, but I don't know if you have any opinion on that. If what should be replaced? I mean, if there is any replacement there, or I don't know.
Maybe first question, Fadi, is what do you understand about a signal?
I mean, all the communication about, so for example, CAN bus, you know, all this communication which is happening about the bus system, like CAN, LIN, FlexRay,
Okay.
you know, all this. This is making components very tightly coupled.
Mm-hmm.
And I think this is a big blocker actually, also for some kind of virtual environment. You know, I mean, I think this, in my opinion, it's quite difficult to have a really modular approach in the automotive if you still are so, you know, you use the signal-based communication.
Mm-hmm.
But I'm not sure if you get how much naturally part you can get rid of if you're putting stuff
Exactly,
together.
yes,
But the car is still a distributed thing, right? Because
exactly, yes.
it will be small computers in different parts of the vehicle, and maybe you're like bringing in, okay, the lights. Maybe that application will be running in a zone controller or in the ECU that's tightly connected towards the lights. But I would say if you can do that division from a software perspective, what the application developer needs to know, okay, I want to develop my application, and I don't really care if I'm pressing on the lights, if that's CAN or lean that goes. I just want to press application, lights on, okay, then I'm fine. And then you have the middleware, right, in the operating system. That somebody else takes care of that. That's naturally very important. And then you have the signals that goes, okay, that's CAN or lean. But if you can take care of that different abstraction layers, and going back to the virtual testing, because that's what we are doing as well at Remotive Labs, we're sending CAN and Ethernet and some IP already in the virtual environment, meaning if you're having an application in the virtual environment, it will be the same message that goes in the hardware environment. It'll be a CAN message that goes.
But can you ensure the interface? I mean, the conformity of the interfaces. Actually, I mean,
it's the same signals, and actually there'll be some hardware restrictions when you actually put it on hardware. But it will be the same CAN message that goes. It will connect to this. Will talk to the same IP address. I'll know. Okay, this. The light will have it will have this MAC address, whatever more. So you get like as the software should be, the seal environment should be as similar to the hardware environment as possible. Naturally, you can't do everything, but still on application, lights on. Okay, I'm sending the CAN message or lean or Ethernet, whatever it is. From application perspective, I don't care, but I see that the lights are turned on, because then you can start to develop and test your integration in an early way, and you can do a lot of stuff then in a virtual environment as well. That if you're getting this like openness and stuff and collaboration, just think of personalization, how much you can do with that. If Fatih goes into the car, okay, I want this specific feeling in the car. I want the seat heating to be on level 3 always when it's below +5 degrees. But my wife, she wants just level 1 on the seat heats. And these kind of things, it's tricky to do if you have the black box approach. But if you're looking at more from an application perspective and you start to develop this whole system in a virtual environment with openness and collaboration, and getting the abstraction layers, application, middleware, OS tightly connected to hardware, and then beneath you have the messaging on CAN, lean, whatever.
Just one question back to ERR. Actually, were there any claims from OEMs on ERR to have an SDV or so, that their car is an SDV, or all OEMs were claiming this?
No, many are talking about SDVs, and then you will think of what does SDV actually means, and who is doing something. And I would say most of them are probably claiming that I have some kind of SDV, but what does it actually mean? And does it mean that I'm taking ownership of the software in the vehicle and that I have a vertical integration?
Okay, but coming back to the ownership, I mean, we talked about this before also, that OEMs usually traditionally didn't have this ownership and just outsourced to suppliers. I mean, how this can, so to say, be now taken back? from the OEM perspective. I think this is quite important for the future of automotive. I mean, if OEMs not don't take this ownership, I mean, I think this will be very difficult in this context.
Yeah, think if the OEMs could have the virtual vehicle up and running in their cloud environment from day one, and then you invite your suppliers as well to that same virtual vehicle, meaning that they can start to develop their application in a context that talks CAN and SAM IP and Lean from day one. I don't need to share my code with anybody else. That could run like in a container in a black box, but at least from a messaging functionality perspective, I would get the right behavior, because then you can have supplier A developing ECU A and supplier B testing ECU B, and then OEMs have their own development, because then you can test everything and iterate continuously.
I mean, this digital twin will be, so to say, some kind of collaboration platform for all contributors, so to say.
Correct, because then you can get in like all partners, because it's not all OEMs that want to take the actual software development in-house of everything, but at least then you get the ownership of it. You can control things, and instead of like sending Excel sheets to the suppliers, you more have like this is my executable specification. This is the behavior of the ECUs. These are my test cases. You should pass them. And then you can continuously iterate. It's much easier than to update. Okay, this test cases, I have some improvements in it. Get it into the virtual environment. You should still pass it instead of sending out Excel sheets.
Yeah.
There is a very concrete topic question from Andrew, actually, about this virtual testing. Are also timing issues addressed by virtual testing? I mean, I cannot believe this, actually.
Naturally, it depends on how you do things. This is one of the tricky things as well, but it's always, is it hard real time or not? Yeah, I would say maybe it's not if you're running in a cloud environment or on a Linux PC. It's tricky in that sense if you're sending CAN and Lean and SAM IP over a network to get hard real time. But from a functionality perspective, you can still reach a lot and with applications talking to each other.
Or they can give an update. So there are solutions where you can provide the deterministic behavior and where you have an own simulation time, and in the simulation time you are able to provide messages on point. You have to define what the simulation time base is, or for example, microseconds, or if you go beyond microseconds, it gets more and more worse for the execution time because you have more samples to calculate per second. But it is possible, and that is possible with tools like Silver and DPT. So they are provided out of the box to get the simulation time on early stages, even on unit level.
I mean, for example, I mean, if I have a brake ECU, for example, I mean, timing is very critical here. You know, your brake has to brake on time, otherwise you have a safety issue. I mean, you could in principle test this in a virtual environment, also with timing.
I can test applications on small or bigger units. So the background is that we provide an indication of a simulation time and run each sample by sample, and we provide input stimulations and measure on these timing samples, and so we can discover issues or timing issues even on any kind of software level by just providing the information what is the sample time. Okay. It's not accurate regarding real world environment and with all these struggles you have in a real world environment, because of on a software level, for example, you don't have these timing issues from CAN message and the asynchronous communication. But if you extend that and you choose let's say nanoseconds or microseconds or whatever your base is, you can say when the CAN message should arrive, and you can also variate that. But normally you want to have a deterministic behavior to ensure regression testing with the same input, same outcome that you can map that.
Okay.
That is one reason why you
okay.
also should go with unit and smaller integration tests on the lower OS parts to ensure that the CAN messages handling is working in a proper way.
I mean, in automotive, it's a very common concept that vehicles are developed SOP driven. You know, I mean, you have some SOP deadline. You have to figure out how to reach this with hardware and software at the same time. But I think in the context of SDV, where software and hardware is actually decoupled, and software can be developed almost independently of hardware, and hardware also independent of the software. I think this is from the concept point of view very interesting, and also I like this idea, but I think it's quite far in the future. I don't know, this is so unrealistic actually, or currently unrealistic.
When you look to Tesla, they do it. So their first release is always a project, and then they work in a product development approach where they're deploying updates for entire fleet. So the main idea behind is that you just continue developing and be able to update the software, monitoring, okay, deployment, okay, but don't stop at SOP and use the baseline you reached at SOP. So you always have an SOP if you have hardware in place. It's a product. But afterwards, you just say, all right, I want to have a new feature. Okay, put it on top of my stack. Make a check in a software virtual environment, make a recheck on hardware as well, because you don't want to have any kind of regressions on a hardware level, and then you are able to deploy that.
But shouldn't, I mean, in the SDV context, if we really decouple both aspects, you know, hardware and software from each other, shouldn't we go away from this SOP thinking at all? I mean,
I think that you still have the name. It's SOPs, like you launching the car, the hardware platform in some sense. But it's not. You should think of that. That's not the end goal. It's more the starting point, because then you get the hardware out, and if you then have the virtual vehicle running in the cloud, because then you have the reference. Okay, this is the same software applications and functionality that I actually have in the car, because then you have that as the reference as well, and naturally you can continue to test on hardware as well, but you can invite all your suppliers. Okay, now I want an update to these two ECUs. Could you please, dear suppliers, work together in this virtual context and getting them to work together?
But this is exactly the point. I mean, SOP is considered as actually the end. You know, the end of something. You know, your product is coming to an end, and you just ship it to the customer. But I think this is a mindset which has to be changed. I mean, SOP is actually a start, like the name says. Start of production is also start of delivering something. And I think this is missing at the moment. You know, I mean, this is missing.
That's
this
is not the end, right? The nice car comes out with all the nice leather and stuff, and then you can add features, because if you're changing the mindset there is a bit and looking at what do I as an end user want. I want new and better features. My car feels alive all the time. But as you mentioned, Fatih, there needs to be a bit of change of mindset and taking this more vertical approach, and actually as an OEM to take ownership. And I have my own experience with this failing, like a car that I had, very nice, not Swedish, but still very nice, where the car got an OTA update to the vehicle, but the car never wanted to actually get it in there. And then it sat there for a month and then timed out, and I get no error message. Just, okay, the car didn't want the updates. I was thinking, what happened? So I'm calling like the connected services, whatever, like, yeah, but we're just a support organization. I have no idea what happened. Yeah, well, did you drive around? Yeah, I was driving 6,000 kilometers because I was on vacation. So the car had time to do the updates. And then you going to the garage. Yeah, but we don't take care of this. This is not part of your maintenance deal. You need to pay extra, but I still have maintenance and warranty on the car. Yeah, but we just change brake fluids on the car. And so there was like no responsibility for this either. You need to, as an OEM, think, okay, this is vertical approach. I, as an OEM, in some way need contact with the end customer as well, and getting features down and also feedback back to the OEM. So getting this also iteration going on that sense.
Okay. Okay. But what about okay, if we consider the current European, especially European OEMs, there's a certain, skill set available at the moment, and does it also need to change the skill set? I mean, to push, to push in this direction of an SDV, that becoming an SDV organization, so to say. I think the current skills probably are not sufficient. I mean,
I think a lot of it has to do with mindset, and there is a lot of silos because there is like, okay, somebody has to be responsible for this thing, responsible for another thing. It's like, okay, I'm responsible for ECU A, somebody else is for ECU B. Software developers, that's one thing. Testers is some other things, and where is like the more the horizontal. Okay, here is I'm responsible for the integration of the software in the vehicle in from a software environment, and how many has actually had an head of software that takes some kind of an overall approach of software in the vehicle.
I just want to add, Emil. I think that was multiple times announced by me, but just to repeat, what I see is there's also a needed change in automotive spice, to say it in that way. So if we look at automotive spice, we see our requirements, allegations of a collector requirements. We have a system development approach, so a system what we want to describe, and then there is hardware. Mostly we derive from system level requirements, hardware requirements for ECUs, and then we derive the software requirements from the hardware requirements. So that has changed because if you want to reuse the software over multiple hardware generations, they cannot be derived from hardware level. So it's not possible. We need to derive the software requirements from the system level. On the same way, we need to also derive hardware requirements from the system level in comparison with the software requirements. So software goes one level up, or you could also say you need to provide hardware where the software can be run. So maybe it's more like in a until SOP, it's like on the same level. After SOP, software is already available. That doesn't mean any kind of software. It means like the functional software based from system level requirements to fulfill all the features and capabilities of the entire car. Because what you said are, from a software point of view, from a functionality point of view, I just need the interfaces. And the interfaces, I don't care if it came from CAN, from LIM, from an I/O port, from whatever it is, Ethernet. It came from wherever, but I need an adaptation where I can rely on my features, check my feature set with all the applications and showing the, I would say, horizontal functionalities, end-to-end functionality of the customer feature. But I also have to integrate it into the hardware. But if my hardware changes over time, more power, different kind of interfaces on a low-level communication driver, so it must be adaptable, it must be fast enough, it must be safe and secure. But I have to deploy my software, let's call it software platform on it, and that has to work. And then I have to describe on a, I would say hardware or a software interface, and there are software parts above platform and beyond, which is like the abstraction of the hardware capabilities to the software platform to provide the necessary interfaces for the features. And that needs a lot of changes from architecture perspective, from all the software development approach, maybe new or other principles in the tooling, and different kind of integration strategy for hardware and software. So there's a lot of to do. And if you go long term with software, from my past experience, it is always a good idea to go with experts, knowing the system context, knowing what's happening in the car, knowing what's going on in the hardware, what can be happen. You need experts, and you should not change the experts. If you go into financial purchasing, we have these sometimes 2-3 years contracts with suppliers, which are having sometimes an experience over 10 years into software application development. And now they're all cut off. I think a lot of people know that for cost reason. And you lose a lot of competency of knowledge about your tooling. And then you go to there are really great people in India and testers. I know a lot of them, and are doing a really great job. But what you cannot buy is 10 years experience of your in-house developed competency, network to people, relationship, people drinking some beers on events, knowing each other, trusting each other. That is what you lose when you cut it off. And that is also something OEMs, tier ones, manager have to keep in mind. That is really important to have these experience in-house or available with long-term partnerships, however you want to set it up.
Yeah, and it's probably going back to like taking the ownership again, because that's also connected to people and getting a mixture between the old automotive guys that actually knows the system, but also like thinking of, if there's more and more software in the vehicle, how can I attract software talent from the outside as well, from the tech companies? And probably you do that in a more open way as well. Can I use standard things that are already out there, programming languages that everybody else is using, and not making stuff up that we in automotive have been doing a bit, maybe too much sometimes, with proprietary things continuously, because then you can attract software people from the outside as well and fill in the gaps. Okay, now I need somebody developing this cool application.
I've just read this interesting comment, actually. I mean, from Mark Alexander. SOP may not be a finish line for software, but I wonder if we can come to a point where it isn't a stop for hardware and other parts. I mean, I understand it in a way that you have your car, and the hardware is developing further. You know, I mean, it does not stop. Your head unit is developing, your brake ECUs, everything also on the hardware level develops like the software. I mean, we always talk about software in the SDV context, but I think it's also important to consider that hardware should also develop. For example, if I want to upgrade, my head unit, it should be possible. I go to the garage or even I can do it. I just order by Amazon the head unit, and put it in my car. Like I can do it for my laptop. If I want to upgrade my laptop, I don't know, the RAM or whatever thing or hard disk, I just order this from somewhere and then just plug it in and it's upgraded. But I think this would be my dream, actually, to be honest. But I'm not really sure if this could be a way, or if this is achievable in automotive at all. That software and hardware really independently develops further after SOP. I mean, software for sure, but hardware I'm not really sure.
Yeah, there is actually also hardware changes to it, and I know that there are like infotainment system that's like pluggable, so you can actually change the hardware it's running on as well, because then you can get a more powerful chipset to run, because then you can run more fancy new things that you didn't know 5 years ago that you would need. But then you just in the mindset there as well. Okay, I need to put this infotainment box should be easy reachable, and some kind of plug-in infrastructure. Okay, I have an easy Ethernet switch I could do, and then I can go to the garage and pay whatever X amount of euros for it, and I'll get a new hardware that's more powerful, and you'll get a more snappy experience in the car.
But I'm not really sure if this is possible nowadays. I mean, at all, because if the car is shipped to the customer, it's done. I mean, I don't know if there is further hardware development for this car line at all. For the next car line, probably yes, but not for the car line which was delivered to the customer. I mean, the software probably will still be developed, but on hardware side, I don't think so much. But would be really cool. I mean, I would love.
I guess that's up to the OEMs to have like a hardware maintenance or whatever. You should do a hardware update team as well, so they can see, okay, now we have this generation of hardware. I want for in 2 years time, I want to upgrade to the new version, and just thinking of it from day one and having, okay, this is easy pluggable. I can exchange this hardware, actually get the new chipset from my vendor up and running as well, with double performance and more features in there.
We're almost at the end. I mean, I have so many questions still. I mean, the long list of topics are still open. Do you have any last words you want to share with the audience?
I just saw one comment from Alexander, or Mark Alexander, that software requirements in automotive are not derived from hardware requirements but from system level. Yeah, that is right. But what we see in automotive is that there are specific teams for ECUs developing and also for the functionality, and normally they capture that by organization, and that is what I mean from this point of perspective. Automotive SPICE is not saying hardware, software requirements. They're both from system level, but system level means ECU level. Especially from my past experience, maybe it's different in some other organizations. But we see, maybe my last words for today are, it's a quite interesting topic. We have a lot of knowledge, especially in our comment list. So I'm really happy to be part of the podcast today, Fatih. Thanks for the invitation. Yeah. Emil, was a great exchange with you. Looking forward for further discussions.
We should definitely continue. We should definitely continue this conversation soon. I think there are a lot of questions, also a lot of topics we have to talk. But Emil, I just want to give you also the chance. Finally,
and thanks for the invite. I think it's a lot about collaboration in this business. Like, a car is a complex thing with this distributed thing. So how can you start to collaborate in an early way? You shouldn't think silos. See if we can break them and do a lot of things together in an early way. And like the hardware thing won't go away, but you can do much more in the soft environment and getting rid of the issues, and don't wait for anybody, and it's more easy to scale. So think of what could we achieve, so you actually, and not maybe having the goal that the car model should be launched in a year and a half. Maybe it's enough with 2 or 3 years, but note, okay, this is when it will be launched, and we're collaborating between the teams, departments to actually make this happen, and also inviting the suppliers to the game as well, and not just sending Excel sheets to them.
These are great last words, I would say. I mean, I take away collaboration as the future for SDV. I think. Thank you so much, Emil and Robert, for this nice talk, and also the audience for the questions. Stay tuned. I mean, next episode will be probably also very interesting. See you then. Bye.
Thanks, everybody. Bye.
Bye-bye.